Today we are going to solve polynomial equations, meaning we're going to find zeros or roots or x-intercepts. So when we find all solutions for each polynomial, notice we have two primary steps. The first one being we're going to make the polynomial equal 0. And then we're going to factor if possible and then use the zero product property to find the roots. So let's look at our first example. Remember what we want to do is we want to have it equal to 0. So we're going to have to subtract that 3x to the left-hand side. When we do so, we have 2x cubed minus 5x squared minus 3x equals 0. Now we have to ask ourselves, well, how are we going to factor it? Hopefully you recognize that you can factor out an x. All three terms have an x in common. So when we do so, we have x times 2x squared minus 5x minus 3 equals 0. Now, you could use quadratic formula with that trinomial, or you could factor it. Remember, when we factor, we're going to take the front, times the back. Okay, so 2 times negative 3 is negative 6, and we want factors of negative 6 that add to give us negative 5. And we want the signs to be different because when I redistribute, I want to have a positive times a negative. So we're going to use 1 and 6, and we want the 6 to be negative. So here we go. We have x times 2x squared plus 1x minus 6x minus 3 equals 0. And now we're going to factor. Okay, so we have x, and then notice we're going to factor out an x. We're left with 2x plus 1 inside. And then in the back group, we're going to factor out a negative 3, and we're left with 2x plus 1. And all that equals 0. So x times x minus 3 times 2x plus 1 equals 0. And we set each piece equal to 0. So if x equals 0, x equals 3, and 2x plus 1 equals 0, that's going to give us x equals negative 1/2. Now remember, when we solve, I want to look at this exponent, the leading degree. That tells me how many solutions we have. So notice we should have 3 solutions in our final answer, and we do, and we're ready to move on. For our other example, we're going to follow the same process. We're going to subtract the 6x cubed, and remember we want to write it so that it fits nicely. So 3x to the 4th minus 6x cubed plus 12x squared equals 0. And now we're going to ask ourselves, okay, is there something that all those terms have the same? Hopefully you recognize, well, they all have a 3 and an x squared. So x squared minus 2x plus 4 equals 0. Okay, factors of 4 that add to give me negative 2 with the same sign doesn't exist. But we do know we can set 3x squared equal to 0, and we do get x equals 0. Now, because of this little 2, we have to say this is a multiplicity of 2. Okay, so there's 2 of our 4 zeros. Okay, so now from here we're going to do quadratic formula because we've recognized that this isn't going to factor. When we find our discriminant, negative 2 squared minus 4 times 1 times 4. 4 minus 16 is negative 12. X equals negative b, which is 2, plus minus the square root of negative 12, all over 2 times 1, which is 2. Now, if you recall, the square root of negative 12 will give us plus minus 2i square root 3. Remember, you have to square root a negative one, you take out the i, 12 breaks down to 4 times 3, which breaks down to 2's. And this is all over 2. What number goes into all 3? Well, 2. So 1 plus minus I square root 3 over 2. So now we're going to say, okay, because we have this 4, we need to have 4 zeros. So notice we have 2 zeros at x equals 0, and we have 2 answers here. You have 1 plus I square root 3 over 2 and 1 minus I square root 3 over 2. Take a few minutes and try the 2 example you tries. Okay, so hopefully for the first example, you get x equals plus minus 1 and x equals plus minus 2i. For the second one, you do have to move the 5x to the fourth and the 2x cubed to the left side with the other terms. And when you combine like terms, you should get x to the fifth minus 5x to the fourth plus 6x cubed. Factor out the x cubed, factor the remaining trinomials. So your final answers, you have x equals 0 with a multiplicity of 3. And that counts as 3 of your solutions, and you have x equals 2 and x equals 3. So let's review all the ways we know how to factor. Notice the factor out the greatest common factor, that's just what we looked at. So if we look at the sample problem, 15x to the fourth minus 20x cubed plus 35x squared, we could factor out a 5 and an x squared. For quadratic trinomials, we want to find factors with product AC and sum to the middle term b. So if we look at our sample example, if I take 6 times negative 10, that's negative 60, and factors of negative 60 that add to give us 11 would be 5 and 4. Okay, and it does factor to 3x minus 2 times 2x plus 5. Now, if you needed to, we can zoom in and talk about that. Okay, so we could say that this is 6x squared minus 4x plus 15x minus 10. And then we can do our grouping method. 2x, and then we're left with 3x minus 2. And then plus 5, and we're left with 3x minus 2, which is how we get that other answer, 3x minus 2, 2x plus 5. Okay. If we look at perfect square trinomials, if we look at the x squared plus 10x plus 25, notice that factors to x plus 5 quantity squared. And if we look at x squared minus 10x plus 25, that is going to factor to x minus 5 quantity squared. For the difference of squares, remember if we have a perfect square minus a perfect square, we take the square root of them and change the sign in between the two between the two terms. So 4x squared minus 25 ends up being 2x plus 5, 2x minus 5. To do the factoring by grouping, we've already illustrated that with the quadratic trinomials. We would factor out the greatest common factor of the first two and the last two, and then do the greatest common factor again. And remember with the sum or difference of cubes, remember we use our FOPL. So you still have to write this a minus b or this a plus b, as we see here in our numeric examples, right? So u would be 2x because that's the cube root of 8x cubed, and 1 or negative 1 would be the cube root of 1. And then we FOPL first term squared, so 2x quantity squared is obviously 4x squared, right? And then remember that O is the opposite sign. So if we are looking here, we have plus, so the opposite sign would obviously be minus. And if we look at the other one, opposite sign of minus is plus. Product of uv, so 2x times 1 is 2x, and then the last term squared, which is always positive, 1. If we look at our next examples, notice that we're going to find all solutions to the polynomial. First things first, we want to make sure that it equals 0. So let's see, we'll have x to the fourth minus 3x squared minus 4 equals 0. Now this one is unique. I want you to think of this like we're factoring x squared minus 3x minus 4 equals 0. And before we said, okay, factors of 4 that add to give us -3. So we would say -4 and +1, just like we would do before. But instead of an x to the first power, what we'll actually do here, something very similar, we'll do x squared. Because isn't x squared times x squared x to the 4th? Okay? And then we'll just move that -4 and that +1 over. And you can factor x squared -4, or you can set each piece equal to 0. It's completely up to you. So here we'll have x squared equals 4, and then when you square root, remember you need plus or minus in your final answer, otherwise you don't have all your solutions. And for the other guy, we'll have x squared equals -1, x equals plus or minus I, because it's the square root of -1. Now, remember I have a degree of 4, so I should have 4 answers. We have 2 here and 2 here, so we're good. If we look at this next example, we don't have the difference of squareds, but we know that 27x cubed and -1, those are perfect cubes. So we're going to say u is equal to 27, or cube root of 27x cubed, which is 3x, and v is going to equal the cube root of 1, which is 1. And notice we start off with subtraction, so we're going to say 3x minus 1, and now we're FOPL. Our first term squared is 9x squared, opposite sign is plus, product of u and v would be 3x, and then the last term squared is 1. So when we set the next group equal to 0, notice we'll have 3x equals 1, or x equals 1 over 3. Now, if we look at this group here, factors of 9 that add to give me 3 isn't going to work. So we have to do quadratic formula. Okay, so let's see. We'll have 3 squared minus 4 times 9 times 1, which would be 9 minus 36, which in this case is -27. And then we'll have x equals the opposite of b, -3, plus minus the square root of -27 all over 2 times a, which would be 2 times 9, which is 18. So x equals -3 plus minus 3i square root 3 over 18. Remember, you have to break down the 27 in a factor tree, and you need an I in your radical for the negative. So x equals, when you reduce, everything's divisible by 3, -1 plus minus I square root 3 all over 6. So notice our degree is 3. We have one answer here, and we have 2 answers here. -1 plus I square root 3 over 6, and -1 minus I square root 3 over 6. Take a minute and or a few to try the 3 example U-tries. Okay, so hopefully you found for the first x to the 4th equals 16, you can't just 4th root both sides because you will end up missing 2 of the 4 solutions. You have to subtract the 16 and then do difference of squares. You do get plus minus 2 and plus minus 2i. For the middle problem, you have to move everything to one side and then factor. You do get 0, -4, and 2. And then for the third example, the -8x's, they do cancel out. So you have x cubed minus 8 equals 0. You have the difference of cubes. Notice you have your 3 solutions. You have x equals 2, x equals -1 plus I root 3, and x equals -1 minus I square root 3.